Now that I discovered that a vulnerability exists on my target, I'm hoping that I'll be able to find an exploit that will allow me to use and utilize this vulnerability to break into my target. So the first thing that I'm going to do is I'm going to research the number and try and figure out if there's a Metasploit exploit for it. So I'm looking for 2017 5638 and Metasploit. And I don't have to look very far because the first link tells me that there is actually a Metasploit exploit module that will allow me to utilize this vulnerability. And here's the module name. So I'll just go ahead and copy that. And I'll run Metasploit. And I'll say use and the path to the exploit. Notice that the prompt here has changed, so now I need to configure my exploit. I'll type info, and a very quick read tells me that this module exploits a remote code execution vulnerability in Apache Struts, which is great news for me. That means if the exploit successfully runs, I'll be able to get remote code execution. In other words, I'll be able to remotely execute or run any commands I wish, hopefully if I get root access. Which I don't know as of yet. Will I be getting root access or not? That is something to be discovered if we manage to get the exploit running successfully. So let us set up the exploit. There's a few things that we need to configure here, the first being the rhost. So I'll start by setting the rhost, which is the target IP address. And I'll say set rhost and I'll paste the IP. Oops, I just made a quick mistake here. Let me fix that to 132. And I'll run quick check. Remember when I told you some exploit modules, you could run a check to see if the target is actually vulnerable or not. And some modules, they do not have this check. So when you run the check, if the module does not have the check, a message will be returned to you saying that this module does not have the check. However, in this case, when I run the check, I get the message back saying that the target is not exploitable. But this doesn't make sense because Nmap said that the target is vulnerable. So that means I need to revisit the configuration of the exploit and make sure that all the options are configured correctly. And one of the things that catches my eye very quickly is the target URI. That's the same thing that gave us a bit of a hassle with Nmap. When we did the first scan with Nmap using the NSE, we didn't get any results back because our URI was incorrect. And it looks like it's the same case here with Metasploit. So I need to fix that. Let me go ahead and copy the URL that I want to test. And I'm going to set the target URI to the URI that I would like to test. Now I do the check again, and now the target appears to be vulnerable. Awesome. So now all I have to do is type run, hit enter, and keep my fingers crossed. Let's see what happens. It doesn't look like it's working. It says the exploit completed, but no session was created. This is one of the most frustrating errors that you'll see when you're doing penetration testing. As a matter of fact, I get a lot of questions all the time about this. The target is vulnerable, I run the exploit, it completes successfully, but no session is created. I don't get a shell. What's going on? Why is this happening? I'll tell you why. Because every exploit with Metasploit has a number of payloads that you can use. What do I mean by payload? There's a very specific reason why I introduced you to a whole section on shells, bind shells, reverse shells, creating payloads using the MSF Venom payload creator, and so on. The reason because all of these shells are designed to do different functions. So for example, you might upload a backdoor that will give you a reverse shell. You might upload a backdoor that will give you a bind shell. Or you might upload an executable that will run a certain command without giving you a shell. For example, you might add an administrator account. All of these different programs have different functionalities, and these functionalities in essence are called the payload. The payload is what the program will do after it runs on the target machine. The example that we saw in the shells section, when we uploaded the ELF file, the executable file, it had a payload that will connect back to us using a Meterpreter shell. That was the function. That was what it's supposed to run and do. The reason I'm telling you all that, because I want you to know that all of these exploits that we run, we can configure the payload to do different things. Most of the exploits that we've seen so far would give us one of two things, either a reverse shell, which gives us access to the Linux shell, the native Linux shell, or a reverse meterpreter shell, which gives us access to a meterpreter shell. In this case, we just fire up the exploit without knowing exactly what payload we're using. So now we're going to be doing something a little bit more advanced, and we're going to try and experiment with different payloads, because I have a sneaky suspicion that whatever payload is being used by default did not execute successfully. This is why the exploit runs and completes, but we do not get a session, meaning that the payload, the reverse shell or the bind shell or whatever payload is happening is not running or executing successfully. So let's try and change that. Let's try and use a different payload. And to do that, I need to see what kind of payloads I have the option to use with this exploit. So I'll type show payloads. And look at that. All of these are different payloads that I can set and use with this exploit. That's a very long list. I'm going to go with one of the safest, simplest payloads, which is almost guaranteed to work all the time. And this is the cmd/unix/reverse. So this is not as fancy as a meterpreter shell, but that should give me a reverse Unix shell. Very similar to what we've done when we did the netcat reverse shell. So let me set the payload, and to do that I say set payload and the name of the payload, cmd/unix/reverse. Now if I look at the options again, look at this. I have a completely new section in the exploit configuration. It has the lhost and the lport. Try to understand the similarities between this and the reverse shell on netcat. When we did the reverse shell on netcat, if you remember, I had to specify a few things. One, I had to tell netcat to execute the /bin/bash. In this example, I'm using the cmd/unix/reverse, which is the syntax of Metasploit for the same thing. And then in netcat, I had to specify the port that I wanted the reverse shell to be sent to. In that example, I used port 1234. In this example, the default port is set to 4444. So I'm going to leave that as is. And then going back to the netcat example, I also needed to specify my Kali IP, because the reverse shell was going to be sent to me and I had to catch it on my Kali machine. And this is what the lhost means. So lhost here is the IP address of my Kali. Because it's going to be a reverse shell, it will be sent from the target to my Kali machine. So I need to specify my local host, the local IP address of my Kali. Equally, the lport means local port, which is the port that I will open on my Kali machine to receive the shell. I hope this makes sense and I hope it's clear. If not, please go back and revisit the shells section. Alright, let me run this and see what will happen. I'll hit run. And as you can see, the first line here says that it started the handler on my Kali on port 4444. And hopefully by now we know what the handler is because we've seen that in the shell section. And boom, we have a command shell session 1 open. Fantastic. So I have a reverse shell now running on my Kali machine. If I do id and who am I, I'm able to run commands on the target machine. To further verify that I actually got access to my target machine, I'll run the ifconfig and look at that. Here's the IP address of my target machine. So I'm definitely running on the target machine with root access. This is fantastic.